Bonjour, hi, welcome to All Around Azure, the developer guide for IoT. I'm Frank Boucher, your host, and we have a very special day today. It will be fun. We have tons of speakers, and a lot of content to show you. On my right, there's a chat there. You will be able to ask tons of questions. But before we go into the details and see that fantastic keynote, let's just do a little bit tour of the role of conduct. So it should appear in the screen. So of course, today, be friendly and welcoming. There's a lot of people involved. There's a big team working in front of the camera, behind the camera, people in the chat. So be friendly and welcome to everybody. Be patient, be thoughtful, of course. The respect is kind of a given. Please, please, please. And let's be open and curious. So now we'll start with the agenda just quickly. So there's briefly we'll have the keynote with Olivier Bloch and Sam George, and after that we'll have different sessions, short sessions, and after every session we'll have a period of Q&A. Don't wait for your question, ask them as soon as they pop in your head, and we'll answer that in the chat. If they are not answered in the chat, maybe you're the lucky one who got their answer for the Q&A. But for now, let's watch this keynote.
Hello and welcome to the first virtual all-around Azure IoT event. That's your getting started on IoT technologies and on your way to getting certified. And today, joining me, I have Sam George, our CVP for engineering for Azure IoT. I am Olivier Bloch. I am a technical PM in the Azure IoT engineering team looking after communities. How about you, Sam? Give us a little introduction about yourself.
Yeah, Sam George, been at Microsoft quite some time, former developer myself, so developers are very near and dear to my heart. Thrilled to be with you today.
Thanks, Sam. So today, Sam would like to give you a little bit of insight about why you should care about this event. Why would you want to become an Azure IoT certified engineer, and why would you want to go through the topics that we have today for you? But before we go there, think about this event as your launch pad on your way to becoming certified for Azure IoT. You'll get some learnings today about how to connect the device all the way up, how to integrate with business application, how to bring ML at the edge and apply on IoT data. But all of that obviously is in the context of how the business is evolving and how things are growing. And so, Sam, what about the ecosystem and how is the landscape looking these days for IoT?
Yeah, well, one of the great things about being a developer in IoT now is that businesses around the world have recognized the benefit of IoT. IoT gives you visibility into all physical aspects of your business in real time, and businesses just didn't have that insight before. But at the same time, it requires a pretty sophisticated level of development, everything from embedded development to edge computing to cloud solution development to biz app development, and everything that we've been working so hard to provide over the last 5 years makes that easier and easier and easier. So there's really never been a better time to be a developer in IoT. The technology's ready, and there's a tremendous amount of demand for developers in IoT.
Yeah, and what's interesting is, so not only IoT solutions spans from these devices all the way up to the business applications, and that means that you have different types of software engineers that need to be involved, to build the device on one side, connect it, to work on the networking, on the security, but also on the web side of things, right? The dashboarding and the use of the cloud services backend. So lots of different software engineers are not involved. So hence one more reason for people actually to learn about IoT, even if their background is not embedded development. There's also a dimension which I find really interesting in the world we're evolving, is that it's not just software engineers. Now you need to work with data scientists. You need to work with, chemical or physical or mechanical engineers. So it's pretty interesting. And, in that context, Sam, I'd like for you to get people excited. If they're not familiar with IoT applications and solutions, what's your favorite IoT solution out there?
Well, it's hard to say one particular favorite. There's so many that are happening right now, but one of them that I'll talk about briefly is won by a great company in New York City called RXR Realty. And they've developed a solution that as people are coming back into their buildings, into offices, to help keep people safer in this time of COVID-19. And what it really shows, what this RX Well solution, they call it, shows is how IoT, edge computing, AI, and cloud can really help provide solutions that help keep people safer. So what RX Well does is it uses cameras running our edge computing platform, IoT Edge, that are mounted in various parts of the building, as well as sensors. And what it does is it ensures that, number one, people are wearing masks, that there's ensuring safe social distancing, they're staying 6 feet apart or not, that different parts of the building aren't being overly crowded, there's not too many people in one particular area. It's also tied into the building infrastructure itself. So it ensures that there's high airflow, for example, in the building. So all of this winds up meaning that instead of having to go around and manually ensure people are wearing masks and safe social distancing and things like that, that the building tenants and the administrators just start getting alerts when they're not. And then they can go and help, just sort of remind folks to be safe. So all of this is combined then to help really keep people safer in an automated fashion. And it's a great testament to the power of IoT and edge computing and AI all working together.
Nice. And so actually it makes me think, can you give us a little bit insight into what is it that Azure IoT is providing? So customers are implementing these end-to-end solutions, but how do we contribute? What is our role in all of that?
Yeah, so let's talk about the RX Well solution, and I'll talk about just briefly the different areas. We provide everything in the cloud. So we have our Azure IoT Hub cloud service, which is used for connecting to and managing those millions of devices, sending trillions of messages. We have data services, we have business application integration services. You'll hear all about those today. But then out on the edge, we also have our edge computing platform, Azure IoT Edge, that helps developers run cloud services such as AI workloads directly on devices themselves, as well as SDKs for running on devices themselves, down to the very tiniest of devices. So we have Azure RTOS that runs on devices with as little as 50 kilobytes of memory. We have Azure Sphere, which provides a safe and secure endpoint that's monitored by Microsoft and always up to date. And then we have a device SDK that runs on virtually every operating system in IoT on the planet, in every language popular language developers are using today. All of that is open source and broadly supported by our team.
Nice. And on the cloud side of things, we talk a lot about integrating with business applications and so on. So how does that work up there?
Yeah, we make that super, super easy with offerings like Azure Logic Apps, as well as Power Automate. So those two tools, Power Services, I should say, Power Automate and Logic Apps, provide connectors to well over 250 business integration systems, business systems, and not just by Microsoft, lots and lots and lots of different services, SAP, Salesforce, and on and on. And so as a signal is detected in the physical world and you need to alert some business process, we make that really, really easy to integrate with.
Nice. And in our goal to simplifying IoT, so we're building all these Lego blocks, right, to build your own solution. But we also are offering IoT Central, right? Can you give us a little bit, of insights about what is IoT Central and what is it meant for?
So all of the different almost building block platform services that I just covered so far, you can assemble them just like RXR did into these solutions that help fuse the physical world and the digital world and provide insights in real time. What we've learned in our time in market is that not every company has the development skills that are required to do that. And so what we've done is we've put together an offering called Azure IoT Central. And what Azure IoT Central does is it uses all of those different cloud services that I was covering and more. But it puts it together in a very simple to use SaaS offering with a super predictable price per device pricing that gets cheaper and cheaper the more devices that you use. You don't have to worry about assembling those cloud services or scaling them up independently. You simply connect devices to it. You can connect devices in just minutes. And as you add devices, Azure IoT Central uses all of those services, automatically scales up. It provides out-of-the-box rich dashboards, analytics, and then also business process integration. So it takes advantage of Power Automate logic apps. It has continuous data export, so you can export all of your data on an ongoing basis from IoT Central to downstream Azure services. So we've made it super easy. We like to say that IoT Central enables you to connect devices in just minutes, go to production the same day, and scale to any amount of devices, all without needing cloud solution development skills.
Yeah, I've been pretty amazed by the amount of features that are now in IoT Central. Actually, one that is super important for our developers is the APIs that IoT Central exposes. It's not a black box. It's something that you can develop with and around and integrate into your solution end to end.
Exactly
Sam,
right.
what about what's coming next? What's the vision? Where are we going with all of that?
Yeah, so if you step back and look at what's happening in the industry right now, IoT has really gained mainstream adoption over the last 5 years. And the primary use of IoT has been to find insights from, you can think of it as insights from assets, right? HVAC machines or water pumps or elevators, to find the maintenance needs, to predict those maintenance needs, to gain insights from those. But it's really been geared towards the assets themselves. And what we're starting to see now in IoT is that as IoT becomes more and more mainstream, that companies are wanting to connect entire environments. So for example, I'll pick on manufacturing. They're interested in not just connecting to the manufacturing assets, right? The bottling machines or the milling machines or the welding machines. They're interested in connecting to the entire environment, the building itself, all of the people that are in it, the inbound supply chain, the outbound distribution network, and to find insights from that entire environment. And so just late last year, we made generally available Azure Digital Twins. And what Azure Digital Twins is it enables you to model entire environments. So you can model them first. Then you can connect IoT sensors as well as other business signals to Azure Digital Twins. And what Azure Digital Twins does is it effectively builds a live distributed object model that represents that physical environment. And then it enables you to data bind to the physical environment. And then as the physical environment changes, Azure Digital Twins raises events, you handle those events, you implement business logic. So Digital Twins is really the next stage of the evolution of these connected solutions. And then just over the horizon, we start to see businesses starting to partner over the insights that they gain in these connected environments and to provide really, intelligent ecosystems that will all work together. So it's an incredibly exciting time. We made it really easy, and it's a great time to be a developer in IoT.
Nice, yeah, and actually interesting you mentioned digital twins as the hero next big feature or service over here, because I've seen actually lots of different types of engineers very interested in the use of digital twins. Like when you come from a different background, you're not a software engineer, you need to have this level, this graph that allows you to rapidly ingest all that data from various sources, and they don't want to build or having to build these blocks, these things that are not,
it's complicated plumbing. It's hard to get right. It took us several years to get it to market because it's so complicated. But what's nice is that now we've simplified that, and you can simply model in a very flexible language we call the digital twin definition language. You can simply model that any environment, the relationships between things. Send that to Azure Digital Twins, and we'll materialize that distributed object model for you.
Like that. What are we doing to simplify how solution developers connect devices? Like, I know devices is something that is complex by nature. Also, when you want to connect devices from various types, various manufacturers, various places, well, they all come up with their own protocol, their own language, their own way of exposing their data. So what are we doing in that space to help developers integrate their devices with the devices from other companies, partners, whatnot, into their solutions?
Yeah, well, one of the challenges that we saw over the last 5 years in IoT is that there's this incredibly tight coupling between software that runs on the device and software that runs in the solution. So as an example, if your device is hard-coded to send temperature and humidity and vibration, your cloud solution has to be hard-coded to receive temperature and humidity and vibration. And often there's even an expectation about how frequently it sends. And so, in early IoT, honestly, that wasn't a problem. But what IoT is starting to bump up against is that device providers are now wanting to provide devices that can be used generally in lots of different solutions, not just one. And solution providers are wanting much easier onboarding experiences for devices where they're not effectively having to just go down to bare metal on the device and hard code a bunch of sensor information that's coming from the device. So as part of our push last year on digital twins, we introduced and made generally available what we call IoT plug and play. And what IoT plug and play is very simple. It uses the digital twin definition language to help developers, device providers, explain or to attest what capabilities the device has, what telemetry it sends, what state that it can synchronize, what commands that it receives, and the responses that it sends from those commands and things like that. And that's all packaged up in the digital twin definition language for the device that uses the digital twin definition language. Now, when the device first connects, it sends a pointer to its document for this digital twin definition language document. And then the solution can simply automatically adjust to what the device can do. So we showed a demo, and I think we'll be showing that as part of this series, showed a demo where you can simply take a device that Azure IoT Central, for example, has never seen before. And as the device is connected and goes through our device provisioning service into IoT Hub, which is being used by IoT Central automatically shows a dashboard for the device. It shows all the different data fields that the device is sending, the telemetry, any of the state that it can synchronize, the commands that it can receive, all without writing a single line of code in the cloud to configure it. So it's a super powerful way, effectively, to program IoT devices.
Love it. Love it. Well, I hope that we have everyone's attention here. Before we wrap up, Sam, besides having us learn to work remotely and record this kind of events online, right, and also deliver that to more people from the home, do you see any impact from COVID and the pandemic on the IoT business itself?
Yeah, for sure. In fact, we've seen an acceleration. Most companies, we do this signals report. We call it the IoT signals report, where we go and survey businesses from around the planet, about 3,200 different businesses. And what we're seeing in general from all of those businesses is that for businesses that were getting started with IoT or that already had an IoT solution, IoT has, in fact, accelerated. It's much, much, much faster. Now, of course, some of the businesses where they were lights out, where they weren't able to get to, they hadn't done that, an IoT solution yet, and they were unable to get to their physical premises, of course, that had an impact. But even there, we're starting to see return to work and people getting going. So all up, it's really had an accelerating impact on IoT. So again, another great reason to be an IoT developer.
Yeah, so time to wrap up. Thanks, Sam, a lot for your time and your insights. We really hope we have your attention and that you understand how important having skilled IoT engineer is for the business these days. It's really for you an opportunity to grow in your career. We have a bunch of content for you today, but once again, do not stay at just the event of today. We consider that as your launchpad to becoming an Azure IoT certified engineer. And so for that, we have a 30 days to learn it challenge, which is available for you at this link. And what that is a set of self-paced, IoT learning courses that you will have to go through. And if you make it in these 30 days, you will receive a 50% off on a Microsoft IoT certification exam. So I think it's really worth it. And once again, on your way to becoming certified, do not forget to sign up. It's this link or at the bottom of the All Around Azure event. Sam, once again, thanks a lot for your time. Enjoy the event today, and I hope to see you soon. Bye.
Thanks, everyone.
That was excellent. Thank you, Oliver. Thank you, Sam. Very interesting keynote, and I'm all pumped up now for continuing this event with our first guest. So if we can bring it into the screen. Hello, Cliff. How are you?
Good. How are you?
Good. I was about to say good morning, but that's not important today. The time is not important. We are all across the globe working together to present a nice event.
Yeah.
So I'm really looking forward to do your to watch your presentation. Not doing it, you are doing it. Damn it. It's early for me. I should maybe take more coffee. That's what I will be doing in a few seconds.
Yeah, my coffee cup's empty. So
Yeah.
refill later.
So what's coming? What can we expect in this session coming up?
In my session, I'm going to give a brief overview. I'm going to talk about what Azure IoT is and just set the ground really for the awesome speakers we've got for the rest of today. So I'm just going to lay the ground, just do a bit of groundwork, just to make sure everyone's on the same level and same page, and then we'll let the awesome speakers later do deep dives into each section of Azure IoT and Edge and machine learning, etc. So yeah, I'm just going to set the ground really.
Yeah, awesome. And it's clear that you got a passion for IoT just by looking behind you. We see all your. This is not a fake one, right? That's a real background, right?
Yeah, you can't see the benches over here as well, with the 3D printers and bits of IoT and failed IoT bits that I've turned into smoke generators, etc. So yeah, but yeah.
Well, very excited to see your sessions. People, viewers, if you have a question, don't hesitate. Ask it in the chat. You should have a chat by my right. Yeah, that's right. Ask it there. There's specialists that will answer your question. If they don't have the time, then we'll, after the Cliff presentation, we'll be back again together and we'll ask a few questions. So don't hesitate. And Cliff, I'll let you the floor. Have fun.
Thank you. Well, thank you. As Frank said, my name's Cliff Aegis. I'm a freelance software developer based here in London, England. And as I mentioned, I'm going to be giving you a brief introduction to what IoT is and certainly what Microsoft Azure IoT offerings are. We'll then a short snippet on IoT solutioning and understanding how you can harness this technology. And then we'll look at a couple of real-world examples of using Azure IoT. So yeah, as I say, I'm going to talk to you about connecting your physical environment to digital world, a roadmap to IoT solutioning. Let's get started. The first thing really is, what is IoT? What does it mean? Well, IoT, Internet of Things, is a network of internet-connected things, devices. It communicates sensor data up to the cloud and for central processing, and you can connect a few sensors, hundreds of sensors, even millions of sensors. Typically they're embedded devices, so it's a small microprocessor, typically with a couple of sensors connected, be it humidity, vibration, temperature, GPS sensor, that sort of thing. These devices, they're our IoT devices, and they take that sensor data, they connect it via a network up to the cloud, and that data they send is the telemetry. So that is the data gets sent up to the cloud. And as I say, it could be acceleration, velocity, it could be heat, temperature, humidity, it could be a GPS location for doing geofencing of your trucks that are out on the road. All those sensor values get sent by telemetry up to the cloud, and then in the cloud we have the Azure IoT Hub, which streams that data in, and then it's used to process that data and give you the insights. Maybe detecting where your trucks are to make sure they're going to the correct locations, or detecting the building environment. Do we need to turn the heating on or the air conditioning, that sort of thing. Also, Azure IoT Hub can send signals back down to your IoT devices to change a setting, maybe set the alert that the temperature goes above a certain threshold to raise the alarm or to open the windows. Maybe it's to change the GPS geofencing of your trucks to make sure that they stay within the correct area. So that is what IoT is. But let's look at how IoT can be used to enable your business to grow in the future and to take advantage of the changes in IoT. Certainly over the last few years, There's been introduction of cloud computing. We've all heard about it. Somebody else's computers in the clouds, but IoT is now, connecting to that cloud, and essentially we're globally available, virtually unlimited compute resource in the cloud. So rather than just having a computer that's in your own office, you have this resource up in the cloud. So the clouds, you connect your IoT devices, you can ingest millions of data points every second from all your IoT enabled sensors and devices, and you can manage them centrally as well. So you can manage them in one place to manage all these sensors, could be anywhere in the world. And then we move on to having IoT on the edge and the AI. So we can have the intelligence in the cloud to run a machine learning model that can look at our sensor data and make intelligent decisions, and then send signals back down to our IoT devices. But we can also take that machine learning model and put it on the edge. We can move it down to our IoT devices, which means that we can make decisions locally, which means we get faster turnaround time on making the decision. So it hasn't got to transit back to the cloud before a decision is made. And then finally, we have, as mentioned in the keynote, we have the new digital twins technology, which is an opportunity to replicate your IoT environments. Maybe it's your building or your fleet of trucks that are out on the roads. You can replicate that digitally in the cloud. So you can then look at, if we change this over here, how is that going to affect the system? And you can design your system without having to roll out hundreds, if not millions, of IoT devices. You can check it and make sure your system works in the cloud, and works for your environment as you need. But IoT projects, they can be complex, they can be hard, because I've worked with many IoT clients, and as the Microsoft Azure IoT team have, in real business applications, and looking at the benefits that it can bring. But to roll out an IoT project, it can be quite long timelines, and the reason being is because not only do you have your IoT software that's on your device, you've got to design the hardware. You've got to look and pick the correct sensors. You got to make sure that the sensor you pick work for the data you're trying to track. There's no point having a sensor that can track a temperature 0 to 100 degrees Celsius, but then you're trying to look at the melting point of aluminium, for example. It's not going to work. So you need to get the correct sensors, test them, make sure they work. You then need to write the software that's on the IoT device that's sending it to the cloud. You then need to worry about the network connection. It's going to be over a hardware Ethernet connection. It's going to be Wi-Fi. Is it going to be Bluetooth? Is it going to be over a radio frequency back up to the cloud? So once you've built your proof of concept, you have your proof of concept, it works. You get sign off from the board to then go and roll this out across your infrastructure. Then comes the hard part, because you then need to provision all these devices. You need to manage them, manage their connections to the cloud, manage their connections to the IoT hub. And then once you've done that, you need to look after them. You need to make sure that the sensors are sending the correct values up to the cloud. And then you also, now you have all that data, all that telemetry that's being streamed into IoT Hub. You need to then look at the insights. What are you going to do with that data? How is the business going to use this data and connect to the back-end system so that you can gain the insights and the business advantage of all this IoT data that you're bringing up? Just look at how we could solve these typical obstacles using the Azure IoT services. The Azure IoT services have the ability to build this comprehensive environment for you and help you connect all your devices to the cloud, whether it's just a few devices, a few hundred, or a few million around the world. Azure has got data centers all over the world, and you can use that resource and that cloud. So the following capabilities are part of the IoT offerings from Azure. We have device connectivity and management. That allows us to connect our millions of devices and simultaneously manage them as they're connected to the Azure IoT Hub. Make sure that the security of each IoT device is there and it's not being compromised in any way, which means data that could be getting sent is incorrect. And then you communicate back to the devices to make sure that you can set the values, etc., within the device as well. Then you got the data ingestion, and then your command and control. So that basically is making sure that you've got your bidirectional communication. So you can talk to the device, it can talk back to you as well. And then you can, maybe you've got devices that work in over cellular and they only connect intermittently because you don't want to use up too much cellular data and that connection. So you can work the data ingestion and command and control can help you control those devices as well. And then you can act on that data in real time as it comes into IoT Hub and send it to the correct areas of Azure IoT behind the scenes. We have stream processing. That is our live in real-time processing of the telemetry that's coming up from IoT devices, which means that we can stream that in and view the data in real time as it's happening from our millions of devices around the world. And we have workflow management. That is where we take that the insights of that data. So once we've got the data from our devices, we've streamed it in, we've processed it, we stored it in a database, be that Cosmos or SQL database. Then the workflow automation is where your back-end systems, your business tools you currently have, be that CRM system, be that an SMS system that sends messages out to drivers or technicians that are out on site. Your back-end systems can take that the insights from their learnings about IoT devices and use those internally within your business. Because what's the point of having the data if you can't use it? Building on that is our dashboards and visualization. So you can take the IoT data and look at the real-time stream analytics, and you can build a powerful visual a tool using something like Power BI or a Blazor web app or a Xamarin mobile app that can look at that data in real time as it happens, as you see these values change from your IoT sensors in the field. But as I say, sometimes you could be building maybe a building management system. Well, there's some of those have been built already. So the extra bit on as well is the fact that the Azure IoT team have built pre-configured solutions. So rather than start from scratch and designing this whole system from scratch, maybe someone's done it in the past. Maybe the Microsoft and Azure team have helped a company like yours in the past build these systems. So there's pre-configured solutions, which is basically a cookie cutter solution. You can take that and then you tweak and edit and make it fit your needs as an individual business. And that means your time to live is a lot shorter as well. So let's look at, if you was to start a new solution, you're starting out fresh and you want to think about how you're going to build this solution. It can be quite complex. How am I going to make this whole solution come together? Well, we highly recommend the use the Azure IoT reference architecture. You can find this on the Docs website, on Microsoft Docs. And it will give you an idea of how to build your solution out. So you start on the left with your things, the devices you have in the field. Would that be your IoT devices that are connecting up and sending data? On the edge of that, you've got the IoT Cloud Gateway, your IoT Hub, which ingests all that data from your millions of sensors around the world. And then inside your insights in the center there is how you're going to stream that data in, where you're going to store it. You're going to store it in a Cosmos or an SQL database, table storage, blob storage if it's images, that sort of thing. And then that processing is also used to build out your reporting tools as well. And then obviously you've got all the data, you need to take action. And action is your automated or maybe even a manual process, and that is your Power BI, that is your integration with your CRM system, the integration with your Azure Maps for mapping where your trucks are around making your deliveries, etc. So if you think about the IoT reference architecture, you've got your things, your insights, your actions. We'll come back to this architecture in a moment. Let's look at a real life project that was brought on board with using Microsoft Azure IoT services. So this is a proof of concept. There's a team of 5 engineers who were given 48 hours to invent a solution. And they come up with building a better mousetrap, a smart mousetrap. Now, I will say this was a proof of concept, so no mice or other rodents were injured or hurt during the building this proof of concept. They had hard hats and full PPE for the COVID times. But let's look at how they designed and went about looking at this project. Well, first you need to start looking at the opportunities. What are you as a business trying to look for? What are you trying to build that's going to work for you and make sure that the business actually is going to do this? It's not going to be put in the bin of internet of crap, of something that's connected to the internet that really shouldn't be connected to the internet. So if we look at this, they looked at the fact that the rat and mice spread a lot of diseases. People don't like seeing them around their buildings. The traps are monitored, and the technician has to go out to visit the traps, so visit the sites and make regular inspections, which requires time and pay of a technician. It requires mileage of the vehicles to do that. And obviously, a vehicle, if it's not an electric vehicle, it's got the emissions and the environmental impact of that trip. Maybe they get there and the traps are empty, so it's a completely wasted trip. All that time, money, and effort, and the carbon emissions of that truck going there just to check could be completely wasted. The business owners become frustrated if the trap's not emptied. Maybe you decide to only go once a week, but suddenly, all the rodents turn up, they all get trapped, and the traps are full. So the business occupiers of that building could become very upset. Business potential customers, may get upset if the building is occupied with too many rodents. You're not clearing them quick enough. So let's report this back. Then they looked at the industry. It's obviously quite a big industry. 12 billion, it's got an annual growth of 3%. So as an industry, it's growing quite quickly. So how can we, if we were the pretend rodent capture company, how can we take on this challenge and make it better? Well, like I said, let's go back to our reference architecture. Let's look at the things. Let's look at the insights and actions. So the things, we can have a smart mousetrap to trap our rodents, but we need to roll it out across a building and then across many buildings in the city. So we need to make sure that we have the ability to securely connect it to the cloud. Connectivity options, do we have Wi-Fi in the building, or do we need to use 3G and a cellular system to see data in the cloud? The insights, the cloud gateway, in our case, Azure IoT Hub, is what was used to securely accept that data, provide data management and capabilities, and then stream process that information and consume the data so that we can use it in our back-end systems as well. And obviously put the raw data in storage so it can be used later for analytics in slow time, not in real time. You can use that analytics later as well and run machine learning models across it. And then obviously we need the actions. We need the user interface, maybe Power BI or a Xamarin mobile application that can look at the data. But also your mobile app can be used by the technician when they're setting up the devices in the field. They can set where this device is in the building and set its GPS locations and give it a device ID, or from a mobile app using digital twins and Azure IoT Hub to connect it all together. So that is our reference architecture. So they started there, but then they went on and built it up. And we can look at the fact that they took the things, in this case was a Raspberry Pi, and connected the mousetrap with a trigger and sent that data up to Azure IoT Hub. They didn't use Stream Analytics to stream that data in real time. They stored it in an SQL database and then used Power BI to reason over that data and give a visual model to the back-end staff, be that the technicians that are out in the field, or it could be the staff in the office that are managing the suite of IoT sensors. But how does it actually work? How does this, I know what you're thinking. Well, how's this smart mousetrap actually working? Surely it's a really complex system. Well, actually, it's not. It was quite simply just a Raspberry Pi. In this case, Raspberry Pi 2. This project's a little old now. And all they did was put a switch on the mousetrap, as you can see in the image there. And then that switch was connected to the Raspberry Pi. It had a little LED light to say the fact that the sensor had been tripped, and the trap had a rodent in it, and that was sent up to the Azure IoT Hub. So you may think that building an IoT solution, the actual hardware is quite complex. Maybe you're a software engineer and you're used to back end and stuff. But actually, the IoT side isn't as difficult as you think. So it's coming up with that sensor and connecting it to a device. That telemetry data is then sent up to the Azure IoT Hub, as we said before, and it helps build those insights of where this sensor is, where that trap is, and obviously then we have our Power BI dashboard. And if we take a quick look at that, the one they built out, obviously this is a proof of concept, but the one they built out for this project. So you can see it's a fairly simple, it shows a map of where the devices are when they've been triggered. Then it shows a floor plan in the building where that trap is within the building. And then it shows some business insights data, the average time to empty and reset a trap, the number of times that trap's been triggered by a rodent. And and average time to clear. So you can imagine here that a trap is triggered, and it could send a signal to the technician who could be driving past or near the building. It can stop by, reset the trap, therefore keeping the client, the building owner, a lot happier because the trap's being cleared promptly and quickly and being reset. Also, if a trap is not being triggered very often, but they're still reporting rodent sightings around the building, you can then see, well, they're not being triggered. Let's move the traps around the building and put them in different places. Once we have that, though, we can then move on to how do we roll that out from 1 building to 10 buildings to hundreds of buildings around the world. But then we can start to model our system using Azure Digital Twins. We can start to model a building. So we can look at a new building sites or a new area that we're trying to protect with our smart mousetrap system. And we could look at how we put the sensors, where we put them. We could send it some test data and use the Azure Digital Twins to try and model our system and how we're going to integrate this complex system within the environment that we intend to install it. And from that, we could, without rolling out and sending lots of devices down to site, we can test and make sure it's going to work for that site before we do any on-site installation and building work. But, that's enough of mouse traps. The rodents all okay. The hard hats works. Let's move on to something a little bit more interesting for me. I like ice cream, and these ice cream trucks, they frequent cities all over the world. These ones are from Toronto in Canada. And the ice cream trucks travel around the city. As we all know, they play music to let you know that the ice cream truck is on its way. When it stops, the music stops, and then the salesperson starts to sell the ice cream on a nice hot summer's day. But the learnings from that is the fact that the driver needs to know where they're going to drive the truck, how they're going to move around the city to get to the correct places at the right time. And they get to know it over years. But what if you're a new vendor? You want to get your own ice cream truck and set up new. You could use IoT and bring it to your business. And the way you do that is you can map where you go on your travels and how much sales. So if you think about it, in this case, when the music stops and the truck stops, therefore you've stopped at a location, you then start to make sales. You can track those sales. So you can use the trigger of the music and the vehicle stopping, so GPS and a sound sensor, for example, into a Raspberry Pi and store that data. And then you can log the sales that you make in your CRM system. And then you can connect your EPP system, connect those two data sources together when you're back in the office later, and then see, well, actually, I stopped here at this time and stopped there at that time. But the next week, you go a different route and track all that data and store it together, and therefore decide which is the best route to travel around the city to make sure you get the best sales. That's the two solutions that I wanted to cover very briefly. And if you want to learn more about the resources in my talk today, you can go to ak.ms/IoT10 resources. The code for the mousetrap and others, you can go to ak.ms/IoT10, and it's up there on GitHub, and then all the resources for the program are there on ak.ms/IoTLP. However, I know what you're thinking. It's like, well, how do I learn more, Cliff? What do I need to do? I want to become an Azure IoT expert. We can head out to ak.ms/IoT10/learn. That takes you to the Microsoft Learn portal, and there's a predefined course there for you to follow and become an AAC solution architect as well. And that will help you go towards becoming Azure AZ220 IoT Developer certification. That will mean you can get certified and become a certified Microsoft engineer, which means you can get hired in the field. You can stay ahead and get recognized for the fact that you know your stuff and you know what you're doing with IoT and Azure. Now, it doesn't mean you need to be an embedded systems engineer. That was my background. But if you're a software developer, the cloud side of it could be the area you specialize in as well. So head out there. You can go and look at the certification at ak.ms/IoT10/certification. And if you want some resources, maybe Microsoft Learn, you're reading through that, and there's a lot of documentations and little short video clips. There's a fantastic study guide put together by Paul DiCarlo, one of the IoT team, out at ak.ms IT Cert Guides. But if, like me, reading is not your thing, and you're more of a visual reader, you prefer kind of YouTube and Twitch kind of streams, then head out to bit.ly /AZ220, and there's a fantastic Pluralsight author courses out there, and that whole theme from Pete Gallagher and Jürgen and others that are putting together to help teach you the whole AZ220 course as well. If IoT, you're not quite ready for it, and obviously you can head out to Microsoft Learn. And Microsoft Learn has subjects you can learn from all of Azure and C# and any language within the .NET platform. You can learn there as well. So it's a fantastic learning resource. I go there very often and keep up my skill set by using resources and stuff there. But that's enough from me. My name's Clifford Ages, and hopefully you've learned a little bit about connecting your physical environment to your digital world, roadmap to IoT solutioning. Thank you.
You did it. So I can let you take a sip of water or coffee or whatever.
I said I'm right out.
That was an awesome. Like, it's always hard to be the first doing the first presentation. It was a great talk. I really enjoyed it. I'm not sure. Was it Tom or Jerry the mouse in Tom and Jerry? Anyway, I really like it.
Tom was the cat, wasn't it? Jerry was the mouse.
So yeah, I really like Jerry with the little helmet and everything. It was pretty interesting.
The ice cream one. I'm more of an ice cream fan.
Definitely ice cream. That. Well, apparently my camera, has trouble finding me. I'm a big lover of Power BI, and you show a Power BI dashboard, so you definitely got me excited there. I was like, oh, that's awesome. Is it complicated how people can have Power BI dashboard in their projects?
Well, the Power BI, I'm not an expert on Power BI. I'm barely dangerous with using it. My kind of background is more the embedded systems and the sensor stuff. But there's no point collecting the data if you can't visualize it. What's the point? You're not going to make any insights and learning from that. Power BI, there's a fantastic course I just started going through on IoT Learn, Microsoft Learn, which you can go through and learn about the Power BI and the dashboards. I'm not going to attempt to explain how easy or hard it is because it's not my expertise. But there's certainly there'll be an expert in the chat that can help you out there.
I definitely don't need to be an expert to enjoy Power BI. It's really easy to get in, at least. Yeah, I think it was a 5-minute to wow was their main idea. But that's cool. I really like it.
To give you an example, I know office staff quite often use Power BI to build very quick visualizations of their data from maybe Excel and things like this. So you don't need to be a code ninja to be able to use the Power BI dashboards.
In your presentation, you mentioned .NET, and like people were asking, is it mandatory to know .NET or C to be able to program an IoT development?
No, it's not. You will actually find that a lot of people that start out in IoT actually start out with something as simple as Arduino and starting out with the learnings there. So you can write it in Arduino C, you can write it in Python. I've done IoT. There's a little robot behind me. Yeah, there you go. That I programmed with my kids using Scratch programming, and we connected it to a Raspberry Pi. So you can use. I mean, if children can do it using Scratch, which is a kind of Lego block, you can use Python.
Scratch programming. That's the piece of, like, it's not coding, right? It's piece of that you put together.
No, it's like little Lego blocks. You drag and drop the Lego blocks. But then my slightly older son is now kind of switching across to using Python and Java, so he can see the Lego blocks and what that means in code. And if he can get a robot to move using these tools, and then the next step will be connecting that up to the internet to sort of feed that data back as well.
Very interesting. So we have another question from Tom, who's asking, does Azure IoT Hub store or buffer the telemetry, or does it keep only the latest messages?
It takes it in, it streams it in, and then it puts it into, it's quite not a complex system, but it's difficult to explain without pictures in front of me. But it streams the data in, and then you'll have a system like Stream Analytics that will take that data and stream it across into your storage system, be that Cosmos DB or SQL. So it's there, and it has different settings that you can have for how long that data lives. So you can then store that data off. So obviously it's not going to store the data infinitum forever and ever, but it's where you put that data and how you stream that into your Azure backend systems.
Oh, cool. So last question. So It's a long one, so let me read it to make sure I don't forget any pieces. So how do you take your PI puck unit and make it a production ready? An experience in a step from puck to production, aware, like what's most difficult and everything?
Yeah, that's quite difficult. You often find, I've done many projects with clients where we built a proof of concept, and then they say, right, brilliant, let's go. We want 100 of these tomorrow. And that's the difficult part. But if you're aware of how you're going to build this, you've seen the mousetrap solution there that I showed. It was a Raspberry Pi, so you can install the software on that, and then because the Raspberry Pi has an SD card, it's quite easy just to make multiple copies of that SD card and just plug it into a brand new Raspberry Pi. Then, using the power of the IoT Hub, you can control and manage those devices as they connect. So it's all about the technology you pick. I've done stuff where we needed to run off a battery and a cellular connection, and we designed the system. We could have made it a lot cheaper and simpler, but actually it would have been harder to actually build hundreds of the parts and roll them out for the client. So we actually spent a little bit more time, effort, and money in designing the system using off-the-shelf components, what were then easier to use and roll out for that environment. But there are many systems you can buy off the shelf that have IoT connected sensors, humidity and temperature sensors, etc. And there is a list on. We'd need to find a link. I'm sure we can come up to it in the chat later. But there is a list on Microsoft Azure IoT, and they have a list of devices that are pre-configured for connecting to IoT Hub as well. So maybe look there, do a little Google Bing search of those sensors. You can connect those sensors up, and they're pre-built devices that have those sensor values built, those sensors built in for you.
Cool, thanks. Well, there's other questions, but we'll continue with the presentation. So now you could chill a little bit.
I'll hop across to and help out answer the questions then.
Excellent.
Thanks, Frank.
Thank you.
Bye, bro.
Have a good day. So let's just quickly turn again to the agenda just to see what's coming next. So we had 5 sessions, sorry. So now the first one is done. So we'll continue with the session 2 now with Pete, and we'll continue after that with all the others. In every sessions, there's a Q&A, so don't hesitate to ask your question at any time. There's people, real expert in the chat who can answer you. So we found a bunch of super brain. But now I have the famous Pete with me. How are you?
Famous, thank you. I don't know, famous in this room. Thank you very much, Frank. Yeah, good, not too bad. Are you?
Yeah, pretty good, pretty good. Very happy to be part of that event. Like I'm sure you will all convert me. I mean, I have a little IoT and Raspberry Pi stuff, but now I just feel like I'm looking forward to get back to it and do a more project.
Though if you've got a Raspberry Pi, you've got everything you need
to make experiment.
If you've got a Raspberry Pi, you've got everything you need to be able to get started.
Yeah.
So, especially mousetraps,
So, damn, my camera, it's the morning, and I think my camera is not fully awake. So sorry to everybody who's seeing me blurred. Oh, maybe it's better. Maybe it's my face that is not fully awake.
Your camera just needs more coffee.
So I know you're an Azure, you're an MVP, right? And I'm assuming it's in which category? Azure or yeah?
Yep.
Azure?
Yep.
Excellent.
Yeah.
And I know you do a lot of IoT. I know, like Chris mentioned, you have some Pluralsight courses and stuff like that. So I'm very looking forward to see this presentation. I'm sure it will be very nice. Again, don't hesitate to ask your question in the chat, viewers, and I will see you later with Pete at the end for the Q&A. Have fun.
Thanks, Frank. Hi. So yeah, welcome to this session on deciphering data. My name is Pete Gallagher. I'm a freelance software engineer specializing in the IoT space mainly. I'm also a Azure MVP, Pluralsight author, and a community organizer here in the UK. So I like to keep myself busy. So we'll start out this talk with an introduction to IoT, just to lay the groundwork there, and then we'll look at some example IoT scenarios and some patterns for processing data. It's worth mentioning that this is actually the introduction to a much longer session, which I'll call out at the end. So we've seen some tremendous growth in the IoT sector, driven not only by innovation, but also the democratization of technology.
Sorry, Pete. I would love to see your slides, but you're not sharing them yet right now.
Oh, it's terrible. And I had one job.
Oh, come on. Don't be too hard on yourself. Excellent.
See.
They're coming now.
Look at that. So yeah, that's terrible. Okay, so we've got nearly limitless cloud computer storage resources, and we can control a vast number of devices now. And we've seen an explosion in AI technology, not only in the cloud, but at the edge as well. And devices like the Raspberry Pi and the NVIDIA Jetson are driving that somewhat. We've also seen an explosion in Industry 4.0 too, where digital twins are being used to map the environment around us. And we can use that information then to be able to help change our environments and our cities and our governments and even ourselves with things like wearables. So in this talk, we'll begin by looking at the example of smart factories. And here we can be looking at HVAC systems to be able to maintain a comfortable and healthy working environment. Or perhaps maybe a lathe where we could be looking at a machine tool that spins at thousands of revolutions a minute. Or we could be monitoring the production line quality using AI and machine learning, or perhaps the actual raw materials that we've got stored somewhere. But this smart factory idea, we can apply that to pretty much any other IoT scenario we can care for. So at a high level, the architecture of an IoT solution is made up of three components. And firstly, on the left, we've got things that generate the data, perhaps devices that are monitoring the temperature in a factory or the manufacturing process, for instance. Onwards from that, we've got the insights, and that's based on the data generated by the things. And then finally, we have the actions where we take those insights and we can decide perhaps to turn the heating off in a factory when everybody's gone home, or send an alert because a machine needs attention. So we'll start here with the things, and then we can step through several different scenarios, starting with the simplest. And our first example is that of the HVAC that we mentioned a minute ago. And this device has got plenty of processing power, loads of RAM, and it can connect happily straight up to a cloud gateway, something like the IoT Hub, for instance, maybe a Raspberry Pi here. And this generates messages that can broadly fit into two different categories. So we can have telemetry, and that could be things like temperature and humidity. And then we can have alerts, and that could be, say, an emergency button has been pressed. And this message data is going to need to be serialized before we can send it to the cloud. And the data type for that is going to determine how we're going to serialize that. So say we're going to be serializing just temperature and humidity data, then something like JSON is going to be a really good choice for this, because a lot of the back-end systems, including IoT Hub, will natively support JSON, and you can then process that data directly there. For larger binary types, say like images or videos, then perhaps we'd want to choose something like Google Protobuf or Avro. But bear in mind, if we do use something along those lines, then there's going to be an overhead to pay in the cloud later to deserialize that data. And then finally, we'll nearly always include some form of message metadata to be able to determine, say, what type of message this is, whether it's an alert or telemetry, or perhaps the schema version or the device type and things like that. And we can use that then to partition the data later. Next, we can look at gateways, and gateways enable IoT communications across domains. And there are two types of gateways primarily. We have field gateways and custom cloud gateways. Field gateways are most often used when we need to integrate constrained devices that, say, don't have the necessary processing power to communicate directly to a cloud gateway. Something perhaps like a little Bluetooth environment sensor. Field gateways are normally co-located with these constrained devices at the factory level. So that is going to allow the constrained devices to talk directly to those field gateways. Of course, the manufacturing industry has got a long-standing history of embedded controller use with machine-to-machine communications over things like RS-232 and RS-485, and then using protocols like OPC UA and Modbus and so on. So the field gateway then ingresses the data from the constrained devices and sends it on to the cloud on behalf of those devices. Next up, we've got constrained gateways, custom cloud gateways. So custom cloud gateways integrate gateways across different protocols, different networks, different clouds. So a good example would be, say, we've got a factory that's separate to our main factory that's storing the raw materials, but there's no internet access at that factory level. And we need to send the data to the main factory to send to the cloud. So at this point, we can actually use a custom cloud gateway across something like LoRaWAN and the Things network. And then we can process that data and then send that up to the cloud for processing later. Alternatively, we could use something like Sigfox or Particle maybe. Another thing to concentrate on in the Things area are intelligent edge devices. So we should look at why we'd include those in a solution like this. And one of the main reasons perhaps would be if we need some form of low latency response to events. So I mentioned the lathe before, and this is a really good example. This thing is spinning at thousands of revolutions a minute. Now, if, say, something like the ball bearing, one of the ball bearings was to fail in that and it starts vibrating, if we're sending messages constantly to the cloud and we're processing it through an ML, an AI system, and then we're using that then to decide whether or not we need to shut the lathe down, that whole loop could just be too long. So what we really need to be doing is offloading all of that logic down to an intelligent edge device that can make those sorts of decisions locally and fast, so that we can stop that lathe immediately and stop it from spinning itself to bits. A good analogy here is our peripheral nervous system. So if you imagine you go and touch something hot and you immediately take your hand away from that, well, there are little nodes in your spine there that are controlling that sort of reflex action. And when your hand comes away from that hot thing, those nodes just send a message to your brain to say that an event's happened. So that's sort of a good analogy in that respect. Another good reason would be that this lathe is just sitting there spinning, and you might be monitoring its temperature and its number of revolutions per minute and torque, but for the most part that data is not changing. That's constant, consistent data. So what you can do is you can process that data down at the edge, and you can perhaps aggregate it together and then just send a block of data with the most important bits of data up into the cloud and deal with it later. Another reason is that perhaps we could be monitoring a production line. So we're taking either videos or still images. And again, that data is pretty consistent most of the time. And so we can train our ML models to run at the edge here to detect any problems. And only then do we send information up to the cloud. So now that we've got the IoT data in the cloud, we should move on and start looking at the insights. And the first thing we're going to want to do with this data is store it somehow. And we can perhaps partition this data by telemetry type, whether it's an alert or just telemetry, or the device type or schema. But storing all of this data in one place is generally a bad idea, because not only is it going to be slower, but there's going to be a cost implication there as well. So what we tend to do is, for data that you want to report on and against, we store that in something called warm path storage, and that allows us easy access to it, but that generally tends to be more expensive. So for data that's just ongoing and we're perhaps going to use that to train an ML model later, we could put that in cold path storage. And that's going to be a little bit more difficult to get access to, but it's going to be far cheaper in the long run. Then generally, as this data is going to come in, we might like to transform it in some way. So it's possible that we could have multiple different schema types, and we need to normalize that in a way that we can then store later. On top of that, then, we might want to process this data in some way. So it might be that we need to apply some sort of business process in there. Say the temperature's gone above 40 degrees and we'd like to do something with it. And then finally, obviously, we need to surface that data somewhere for reporting and UI. And so we can see there how the data is flowing through, and we can surface that. Onwards from that, then we've got the insights. Now we need to apply some form of actions, and we want to take the results of those insights and then feed them back in a loop so that we can make better decisions and automate device interaction and things like that. And we might also want to use that IoT data to train machine learning models, and then we can push those machine learning models back down to the edge. And so what you can see here is a typical IoT reference architecture, and we can see how the data is flowing through the system. So I mean, that's sort of the main part of what I wanted to get across. As I mentioned at the start, this is actually the introduction to a far longer session where we'll talk about data enrichment and partitioning and stream processing, where we're looking at Azure Functions and Stream Analytics and Databricks. And we can look as well at the storage options and how we can optimize for performance and cost. And we'll also dive into data visualization and exploration there as well. If you want to go on and learn a little bit more about this particular session, then you can hit these resources up that you can see on the screen. So you can go to aka.ms IoT20 resources for the session resources hub, and you can get the code there at aka.ms/IoT20. And then if data processing is your thing, then there's actually a curated set of Microsoft Learn modules that you can go and step through, and you can get those at aka.ms/IoT20/learn. This session is sort of heading you towards the AZ220 IoT Developer certification, which is a fantastic way to up level your knowledge in IoT, but also it gives you that extra professional edge if you perhaps want to make a sideways step into IoT or progress your career a little bit further. So you can find out a bit more about the certification at aka.ms/IoT20/certification. And if you start taking that, then there's some fantastic resources for you to use as well. Paul DiCarlo's made a fantastic study guide for the exam there at aka.ms/IoT cert guide. There's also myself and a few other great authors authoring some Pluralsight content to be able to take you through in a more visual way. And you can get that at bit.ly/Pluralsight-AZ220. And also, don't forget that we've got the 30 Days to Learn It challenge happening at the moment. So there's never been a better time to go and learn stuff. And the content over on MS Learn is a great way to do that too. So thank you very much. Apologies for the short break. But yeah, that's great. Thank you for tuning in.
There we go. I'm moving on currently. Hey, that was excellent. Don't be too hard on yourself. Like last time we did an event, I was muted, and like I'm the host, so things could happen.
This is true. We could fix it in the retro.
Yeah, that's easy. Don't worry about that. It was super nice. So questions are now queuing up in my here teleprompter. So that would be awesome. So the first one I have, and I'm happy someone else also asking, because that was something I was asking myself. Like, there's so many different type of data. How do I know like the format that I need to use to have the best results?
Yeah, we kind of touched on that in what I was saying there. So this is going to come down to almost the size. So, I mean, if you're talking about something like temperature and humidity, which is small textual-based bits of information, then something like JSON is going to be perfectly fine for that. And the great thing about that is that you can then process that data directly. So something like the IoT Hub, you can then process that JSON data and route those messages out to other services or other endpoints, depending on what you want to do. So it could be that your temperature's gone above 40 degrees, as we said in the presentation, and that needs to go out to an alert there somewhere. Perhaps you're going to trigger a logic app or something to wake somebody up in the middle of the night. But big data, something like images and videos, then you're better off using something like Avro or Protobuf, and that's going to keep those sizes nice and small, or as small as they can be. But then you're going to have to deserialize that data in the cloud there somewhere. So there's always an overhead. There's always a price to pay somewhere.
So it's definitely worth it to spend a little bit of time thinking about like what exactly you want to analyze and pass around and stuff like that too.
Yep, absolutely.
Oh, this is very interesting. So Marcel is asking, is there any preference? Like, how should I pick if I should use a Raspberry Pi versus an Arduino?
I mean, a Raspberry Pi is, that's a full computer, so it's got way more power than most of the Arduinos that you're going to find out there. So it depends on the solution that you want to attain, but if you want to do edge processing, then a Raspberry Pi is a great bit of kit for that, and I've used that for edge processing. I mean, it can run Docker containers, and obviously we have the whole IoT Edge stack sitting there that you can make use of. So that's fantastic for that, but it's not what I'd class as a real-time device, a real-time control device, and you'd use an Arduino for something like that. So if you need sort of millisecond or possibly even microsecond level control over something, then an Arduino is a great concept for that as well. But these days, actually, there's quite a lot of crossover between the two as far as what you can do. But one of the things you might find, though, is that the Arduino, you're going to be writing in C, Arduino C, and there's a whole SDK out there for you to be able to communicate with IoT Hub in that respect as well. So that's perfectly fine. But when you get to the Raspberry Pi, then you can program in Node or in .NET or in Python, and so access to the SDKs makes a difference there. There are some crossovers again, so that you can get something like a Wilderness Labs, and that's going to have .NET, but that's an Arduino. So there are some things to think about when you're choosing between those two.
Yeah. So I'm assuming like if I'm just getting started and I want to start playing with that, like it will be a little bit more. It will be a better idea to start maybe with a Raspberry Pi, because then like I have a PC. So if I'm not doing any IoT, I can use it as a Plex server or something like that. A Minecraft server. I think like it could do a bunch of stuff, right? It's a little PC. But then if I know I have a very specific need, then I may go a little bit more on the Arduino side for having a very specific sensors thing.
Yeah, I mean, obviously there's a cost implication there as well. You can buy Arduinos for next to nothing, whereas with the Raspberry Pi, you're going to need a Raspberry Pi and a power supply and an SD card and possibly some sort of a case. And then, if you need to get access to a screen, then a screen and an HDMI cable and a keyboard and a mouse. So there's a whole plethora of stuff that you're going to need with a Raspberry Pi. You're right, it gives you access to a lot of other things when you choose the Pi. But I mean, the Arduino, you can use that to get started just as easily, and the tutorials out there are fantastic, but it can get quite complicated quite quickly.
So that's pretty cool. Arduino and our Raspberry Pi are very recent. What if, and I'm sure it happens in many enterprises where they have like legacy sensor, how can they use that data from those sensor and like bring it to Azure and do something with it?
Yeah, I mean, again, that's something for a field gateway there. So you can communicate over these legacy protocols with something like a Raspberry Pi or an Arduino, and then you can process that data on the Pi and then send it up in a format that the IoT hub's going to be happy with. I mean, just JSON is going to be fine. So you'd have, and I've used these before, so little perhaps Bluetooth sensors that all they do is just send out BLE beacon data. You can then ingress all of that data on a single Raspberry Pi, acting as a field gateway, and then you can send that up over AMQP or something like that, or MQTT up to the IoT hub, and off you go.
And that field gateway, that's a device that I will set inside my network kind of thing?
Yep, yeah, exactly. Yeah. So somewhere near these devices that have got these legacy protocols that perhaps can't connect directly to an IoT hub, so that you can control them, they can talk to this field gateway directly.
And what if, so I'm assuming it's also taking charge of like a lot of time, like it's a sealed environment when like there's no, so like it's secure and it will be a secure way to pass all the information.
Yeah, exactly. I mean, you could have an air gap situation like we mentioned with the two little factories. One is storing your warehouse, is storing the raw materials, and perhaps there's no internet there. So then you could go up to this custom cloud gateway, and you could go over something like LoRaWAN perhaps to be able to bridge that air gap, where you don't want to put a full internet connection in there if you're security conscious perhaps.
Excellent. We see now the question showing up in the screen. And I saw something about some privacy. I forgot, like it was there a few seconds ago. Maybe someone already answered that in the chat.
I see something on the screen now, Frank.
Oh, yeah. So how can you deal with sensitive data and personal data?
Yeah, I mean, the good thing is that, I mean, from a security standpoint, all of the comms up to something like IoT Hub is all encrypted. So that's one of the real benefits of being able to send data up this way, is that Microsoft have thought about the security aspects. Obviously, what you do with that data after you've ingressed it into the rest of Azure, then you're going to need to take your own point of view on how security conscious you need to be. But Microsoft are most certainly being very careful with this, and things like Azure Sphere, for instance, are tackling the security aspect in particular, where they cover that whole security platform for you. You don't have to worry about any of it, certificates and expiration and all of that lot. But yeah, so definitely you are covered, and the more secure it needs to be, then perhaps Azure Sphere would be the way you'd want to go.
Awesome. One more question. So how much value really the small industry will get from this IoT data?
Yeah, again, democratizing this, and the fact that it's so cheap to actually do this now. I mean, it's pennies to ingress millions of messages into Azure for a start, but the kit that you can use now, Raspberry Pis and Arduinos, I mean, an Arduino, you can pick up something like an ESP8266 for pennies, next to pennies, if you buy it from China, perhaps. So I think that's one of the biggest changes we've seen, is that the cost of this equipment, it used to be 10 years ago or something that you'd have hundreds of pounds worth of equipment to do what we can do with quite literally less than £1 now. So the small businesses are going to be able to take all that data and then process it with ML and AI and improve their whole business processes on a level that was reserved for big companies before.
Thank you, thank you. So before we go to the next speaker, I know you have an event coming up, right?
Well, I've got Knots IoT coming up, so I'm a community organizer. So thank you very much, Frank. It's always good to have a plug. So Knots IoT is now, of course, online, and we've got some fantastic speakers. We've got Sander van der Velde and David Whitney talking, and in fact, Sander's going to be giving a talk shortly, and I believe David's in the chat there answering loads of questions. So Sander's going to be talking about an IoT Edge beer lift, and anything to do with beer and IoT, and I'm in. And David's going to be talking about how he made a Game Boy in .NET Core, which is incredible, and I love retro computing as well. So this is just a beautiful event for me. So yeah, that's on Thursday at 6:30 GMT. You'll find us on Meetup or at Knots IoT on Twitter.
Well, thank you for sharing, and looking forward to see you another day.
Thank you very much, Frank. Cheers.
Bye. So now we'll continue with Gosia. Et voila.
Hello.
How are you?
I'm good, thank you. How are you?
Good, good. We're making people having a hard time in the backstage. So you also an MVP. So we have a few MVPs today as speakers. So what's your field of expertise?
So I used to be Office 365 MVP, and from last year I am an AI MVP.
AI MVP. Oh, that's very interesting. Like, I know it's not that easy to be on the AI side. So congrats. That's very, very nice.
Yeah, thank you.
I know. So you did a little bit of running. So I don't know if you play with your running data in your project, try to analyze them or something like that. No?
So I'm not a data scientist. I'm a developer. So what more I work on is the pre-built AI. So kind of community services, or like we have in Office 365 Project Cortex that's coming on, and it's really exciting bits.
Excellent. Well, I won't take more of your time. I will let you do your presentation. And again, if you have any question, don't hesitate to ask in the chat. People are there waiting to answer them, or otherwise we'll be at the end of a Gosia presentation. We'll have a time to answer all your questions. So the floor is yours.
Thank you. Welcome to the Adding Intelligence, Unlocking New Insight with AI and Machine Learning. My name is Gosia Bożencka, and I'm an Office 365 developer and also a Microsoft AI MVP. Today, we'll talk about what machine learning is and how we can implement it into the IoT scenario. In our world today, many different creatures are on a mission to take our lives miserable. For example, in your neighborhood could live some raccoons, or how they call them in the US, the trash pandas. Or like in the UK where I live, there are a lot of foxes. It's most likely that all countries have their own little enemies that will love to mess up the trash on the streets for finding the food. And this could be a massive problem for everyone. So one day, Carissa woke up and saw the dirty street again, and she decided that enough is enough. And it's a time to build a trash panda defense system and say goodbye to raccoons on her street. She started creating a solution for the raccoon problem and came up with the following design. When the camera detects the raccoon on the trash, the alarm should go on, no sounds, but only lights to not wake up the whole neighborhood. And the raccoon should run away and the alarm will switch off. To build her system, Carissa needed to have a few elements. Raspberry Pi as a device where all detection will be made, camera to check if raccoon comes to the trash, alarm to scare raccoons, and an Azure subscription to control the system she will write. To solve this problem with a camera, she needs to build something that can look at an image and detect a raccoon in the picture. And this is a problem that it's hard to solve with traditional programming, but relatively easy with machine learning. The first important bit is to understand what machine learning is. The most general definition is that it gives the computer the ability to learn things without explicitly programming it. In traditional programming, we have some data and algorithm, and based on that, we got answers. But with machine learning, this is switched. Instead of creating the algorithms, we will need to computer generate this algorithm for us by providing the data with answer as input. And this input in machine learning world, it's called model. What we can do now is we can run new data through this model and get a prediction output about the input. To summarize, we have answers, we have training data, and based on that, we are creating a model. Next, we are giving extra data that was not included in the training data, and we can run again to get our prediction. For the Trash Panda defense system, Carissa would have to create a classification model as she wants to find a raccoon that will show on the images. Carissa will have video frames from the camera to analyze and predict by the algorithm if there is a raccoon or not. And for that, she needs to have three things: a lot of images with raccoon, a trained algorithm, and an environment where she can run this training algorithm. These three things will deliver her model, and she will be able to use it later in her Trash Panda defense system. But what happens if there will become new enemy that love the trash, for example, unicorns? In this scenario, she will need to add some photos of unicorns and retrain the model so it could also recognize the unicorns. And after retraining it, the training algorithm will recognize the raccoons and unicorns. Now that we understand what Carissa has to create, let's look at which Azure toolset to create model can be used. First, there are domain-specific pre-trained models called cognitive services. These models are created, run, and maintained by Microsoft and exposed through an API in the Azure. The only thing needed to access this model will be to go into Azure portal and create the one you like, and by using key and endpoint, you can implement into your application. There are around 40-ish different models enabled, and they are divided into four main areas: vision, to make your application see the world; speech, to make your application talks and listen to you; language, to understand what is being spoken; and search, to give your application information from a lot of sources. But if you dive deeper and want to create a model by yourself, you can bring your own tools and frameworks and use Azure Machine Learning Services, or create a machine learning VM to boost your productivity. And last but not least, there is a lot of powerful compute that you can use to train your model fast and reliable. Carissa can use a few options to create a classification model. One of them is Computer Vision API. They pre-train a large data set that can classify most ordinary objects. It can generate a description of the image tags and tells where the founded objects are. It can also recognize celebrities or read the handwritten text. This is a very easy way to get started with vision models. But not all objects are detected with the Computer Vision API. In Carissa's case, she needed to detect a specific object, raccoon or unicorn, so she decided to go with custom vision services. This service can help quickly build a model for a specific object. The service comes with a user-friendly interface that walks through developing and deploying custom computer vision models. It uses the API to predict images quickly or export the model to a device to run real-life image understanding. Carissa's next step could be creating her own machine learning model with help with Azure Machine Learning. This could help her to have more control about the whole life cycle of the machine learning model, starting from preparing data, building model, training, and deploying machine learning models really fast. This also can enable the team of data scientists and developers to collaborate together using MLOps, so it's a DevOps for machine learning. Now, when Carissa has the raccoon classification model, she needs to find out how she can implement this model into the Trash Panda defense system. And there are, again, a few ways to run a model. So how this will work? The Trash Panda defense system will collect data from the cameras as frames. Then the data will be analyzed by the model that Carissa created. Based on the output, the alarm will be switched on or switched off. There are multiple ways of implementing the Trash Panda defense system. One way is to generate the IoT device data, analyze the data in the cloud, and take action on the device. So the system will send every frame to the cloud, run the frame through the model, send the prediction back, and the alarm will switch on or off. The benefits are to tune the model in the cloud quickly, but it could take a long time before the alarm will switch on or off. Sending all these frames to the cloud also requires a fast internet connections. Another approach will be running the model on the device itself. A common misconception is needed to have a powerful computer to run a model. Still, for a simple model like the Trash Panda defense system, the Raspberry Pi can easily run this model. However, training the model is very compute heavy and cannot be done on a Raspberry Pi, and is highly recommended to do it in the cloud. In this scenario, the video frames are not leaving the device. They are processed locally, meaning the device could even function without connecting to the internet and act without any delay on the model's outcome. The model's output could be sent to the cloud with delay to create, for example, a Trash Panda defense system control center or dashboard to analyze when and how often raccoons or unicorns are coming to look into the trash. Both of these approaches have their own pros and cons. If you look at IoT in the cloud, it is excellent if you don't need a real-time action being performed on the device itself, like remote monitoring and management. Also, in the cloud, you have access to infinite compute and storage to compute intensive AI models. The biggest advantage of running IoT on the edge is that you can pre-process the data on the device itself, meaning that video feed from the camera or any other data generated by the device never has to leave the device. And this is a good thing if you have a heavy security and privacy requirement. For Carissa, the best scenario for the Trash Panda defense system is that the solution will be built, tested, and managed in the cloud and deployed on the Raspberry Pi device to run locally. This will give the cloud flexibility and power to train the model and quickly run this model on the device to scare the raccoons or unicorns. Because everything is processed locally on the device, it is not taking up any bandwidth. And the device could even be placed at a location where there is no internet access. Azure IoT Edge is a fully managed service built on Azure IoT Hub. This service enables you to deploy your cloud workload to run on the Internet of Things Edge service via standard containers. It works with Linux and Windows devices that supports container engines. The runtime is free and open source under the MIT license. IoT Edge runs Docker-compatible containers. In these containers, you can run your own business logic. And through the cloud interface, you can manage and deploy the workload on the device. Azure IoT Edge uses models. For the Trash Panda defense system, Carissa will need to use 3 modules. A camera module takes care of the connection with the camera and extracts the frames from the camera feed. An AI model. In this module, she can run the machine learning model that has been trained in the cloud. And last, a model that will handle the alarm. Every model is a separate Docker container that is sorted in Azure Container Registry. To deploy these modules to the edge device, it's needed to create a deployment manifest This file needs to specify where the models are located and how they should communicate with each other. Via Azure IoT Hub, this manifest can be deployed to the connected device. When the deployment is done, the models run and communicate locally on the IoT edge device. Let's summarize the Trash Panda defense system. On the device, the IoT Edge runtime is installed. By default, this comes with two models. The Edge agent takes care of the models and deployment, and Edge Hub, a local IoT hub that enables models to communicate with each other. On the IoT Edge deployment manifest, there are installed three models. The camera module connects to the camera and sends the frames to the custom AI models. The custom AI models puts the model score on the local IoT hub, and the other model receives the model score from the Edge hub. In the other model, if the model score reaches a specific threshold, the lamp is turned on and notification is put back on the Edge hub and sent back to the IoT hub in Azure for monitoring purpose. In this session, you got a little peek at how you can use Azure IoT Edge and Azure AI to create a Trash Panda defense system. We covered what machine learning is and which tools there are offered in Azure, the difference between IoT in the cloud and IoT on the edge, and how to use Azure IoT Edge to manage a solution. Suppose you would like to see the sample code how the Trash Panda defense system was built. In this case, you can go to those resources and find image classifier service written in Python, camera capture app that you can run on your device using as well Docker, and simple LED switch on off to run your Raspberry Pi device. And if you would like to learn more about custom and computer vision models, you can go to Microsoft Learning Platform and step-by-step be guide how to create them. And also, if you would like to go with Azure certification, the recommended one is AZ220 to be the Microsoft Azure IoT Developer. I hope your journey with AI and IoT now begin, and thank you for attending this session.
Thank you. It was a great presentation. Thank you a lot.
Thank you.
I enjoy your slides with the little raccoon and everything. Did you make those drawing by yourself?
No, it was created by Hank from Amsterdam.
Oh, excellent. In Canada, in Toronto, there's a big problem with the raccoon and the garbage, and they spend a lot of money to do all those analysis and everything. They have the raccoon in their logo to kind of a...
Yeah, so now you can use this code to run on your stream.
Yeah, like I wouldn't show it right now, but I even have a sticker. They gave me a sticker with the smart raccoon. Like they have very special garbage and everything. So I don't know if they use IoT to analyze everything, but maybe they should.
Yeah.
So first question I have for you is, do you need any special device to run IoT Edge? And like the ML models and everything?
No, it can work easy on Raspberry Pi. It can work on your computer, so you don't need a special things because it's a model that's coming to the program.
Okay, and well, what would be the minimum requirement, like in spec, to run it, like to run the AI model, but locally? Or do I need to absolutely?
So first you need to have a model that you will create, and the best is to create this on the cloud because the model is really compute heavy. And for easy one, you can use computer vision or custom vision that will create for you this model. And then you just need to get this on your local device.
Okay, cool. Let me see what else do I have. Why would you want to use object detection at edge instead of the cloud? Wouldn't the cloud be able to run more complex models?
So cloud will for sure be for a big model, but like in this example, like Raccoon, it's really easy to create with custom vision the model and detect on the edge on IoT device. So you don't need to send every single image to the cloud, because it's also heavy and it's cost a lot to send image to cloud and back with the answer.
So it's a question also then of speed. I'm assuming like if you need to send a lot of information in the cloud, like yeah, it's costly, but then it's also, it must take times, right?
Yeah, it can take a time.
So
and
doing it on the edge,
you send this all images, because sending to the cloud and going back, it can take, I don't know, 2 seconds, and it could be too heavy. And on device, you can have just milliseconds and you get an answer.
Excellent. Okay. So yeah, it's definitely a question of times. That's cool. That's cool. Let me see, what else do I have? Question. So yeah, okay. So I have a question from Damas. Sorry if I butcher your name. What do I need to know to be able to train my own custom object detection model to use on Azure IoT Edge?
Sorry, could you repeat?
Yep. So what do I need to know to be able to start creating my own custom and training?
So you can start from custom vision. That it's really easy. It's on the browser. You're just giving all pictures and everything, and it can create for you this model. And it should go with everything what you need. But if not, if you find that it's not, then you start creating your own model, because maybe some algorithm is not working good for you, what is in a custom vision.
Okay, cool. Well, thank you a lot. I'm sure right now I don't have any more questions, so maybe questions will come later. So feel free to join the chat and see.
Yeah, I will be there.
Thank you again, and we'll continue
with
Christopher.
Yes.
Again, sessions are coming, so we are now at session 4, coming up with Mr. Christopher Maneur. Hello, my friend. You're on mute.
Hello, Frank. How are you doing?
Very nice. It's always funny to see two francophones speaking to each other
in English.
Very happy to see you, like, you know. So you're a cloud advocate, just like me. We work together at many occasions. Very happy to have you on board today. What's your session is about?
So my session is about how we can leverage IoT data within an organization. Basically, most of your organization need to analyze some form of data, but most of the time they don't really connect data gathered by IoT system and the classic dashboarding solution. And this session is all about why you should do it and how you can do it with Azure.
Okay, I'm hooked. Let's do it. See you after.
Thanks. See you after. Hi, everybody, and welcome to Big Data 2.0, IoT as your new operational data source. IoT and big data are mainstream for a few years now. If we look at the actual IoT deployments, we tend to see that most of them are actually done in silos, and IoT-generated data mainly benefiting part of the organization that deployed the IoT system. But what happens when a CEO comes in and say, hey, I want all my new IoT data right into the sales dashboard? If you are a data engineer or an IoT engineer, then that's your call to make this happen. During this session, we will see why it's important to integrate IoT-generated data into your data landscape and get an overview of the strategy and benefits of doing it. My name is Christopher Maneur. I'm a cloud advocate here at Microsoft, and I'm focusing on IoT advocacy for the EMEA region. We'll start the session by quickly introducing the challenges of big data and the kind of data IoT system produce. Then we will talk about the challenges of ingesting and storing IoT data and why it can fit your existing data estate. And we will then see why using IoT as an operational data source from your analytical system can unlock insight and actions across the entire organization. So let's start with a primer on big data analytics and data management. Usually speaking, big data refers to a system that produces so much diverse quantity of traditional data that traditional BI system cannot really analyze it. We tend to define big data system with 3 adjectives called the 3V. First, volume, which is simply the amount of data to be analyzed. Then, variety. It's the changing and unstructured nature of the data to be analyzed, as opposed to relational data where all the information is well organized in a table column format. Big data system can cope with semi-structured data like JSON document, or even unstructured data like image and videos. And last but not least, velocity, which is the frequency to which the system produces new data. In the IoT space, it can be as slow as a few metrics per hour, up to million events per second. But maybe these 3 adjectives may not seem abstract to you right now. So let's talk about what is probably the biggest big data project in the entire universe, the Square Kilometer Array Radio Telescope. It's an ongoing international project of radio telescopes based in South Africa and Australia. It will become the most sensitive radio instrument in the entire world. This project is also probably about to become paramount of big data project. This mesh of radio telescopes will provide scientists with 50 terabytes of fresh new data to analyze every single day. This data will be in form of images and radio signals. However, there is a lot more behind it. If we look at the actual data generated by the sensor, we're expecting here something like 7,000 teraoctets every single second. All in, they should store about 600 petabytes of new data every year. Okay, you will probably not to have to deal with such large amount of data. Anyhow, it's a great example of the 3 V's, volume, variety, and velocity, in a more concrete example. Now let's have a look at the variety of data an IoT system can produce. First, we have the telemetry data. Mainly here is JSON document, even if from time to time we encounter a lot of other data formats, like column-encoded ones. Then we will have all the metadata associated with the data itself, the IoT device that generates this data, or even the system. This data may change slowly over time, but they can be precious sources of information for your analytics. In the process of processing this data, we can also enrich this metadata with reference data or data coming from other sources. The diversity of IoT-generated data can be immense. Images and video stream, for example. But with IoT gateways like Azure IoT Hub that facilitate file uploads directly from IoT devices, we can enable collection of all kinds of unstructured data. If we look at the characteristic of IoT data, you will probably see it's well aligned with big data. To achieve these goals of analyzing all this data and IoT engineer will need to work together and understand each other. The remaining of this session aim at creating a bridge between these two worlds. We've seen why IoT and big data share the same challenges about the type of data they handle. We now see why integrating IoT data as a new operational data source is facilitated by Azure solutions. But first, we need to see from where this IoT data comes from. When designing an IoT solution, you will probably get all your devices connected to a central hub called an IoT gateway. Azure IoT Hub is a managed cloud gateway offering within Azure. From there, you can have application, storage, and databases listening to incoming messages from your devices. When you have set up this, you can then route your messages through several destinations. IoT Hub supports out-of-the-box system for several storage systems, like storage account, data lake, and time series insight. You can also route these messages to custom-made application by leveraging the service bus or the Event Hub SDK, or even creating a consumer application with AMQP and Kafka protocols. You could also leverage processing services like Azure Stream Analytics or Azure Function, allowing you to process, enrich, and store your IoT data pretty much anywhere you want in your IoT system. Now we saw where IoT data comes from. Let's see where you can land it. As a first option would be simply to store it into relational databases. In this case, obviously, you will not send all your data, or you will quickly overwhelm your SQL database. But you can send aggregated data and even filtering this data into specific conditions. If you already have a data warehouse solution implemented, you could also output aggregated data to it and leverage your existing BI capabilities. If we look at NoSQL databases, like graph time series databases, they can be an interesting destination. For example, with them, you could create a graph representing your sensor, brew minute, building, and facilities. Doing so, you could quickly query this graph, for example, to get the average temperature in a specific building or in a specific room. And at last, if you have a data lake, you will probably send all this IoT data into it for further analysis. Of course, Azure provides a range of services covering all this type of data source, from the classical Azure SQL to an hosted Hadoop cluster with HG Insights. Some Azure services are a great match for IoT data. You can also leverage open source data source hosted on Azure, like Azure PostgreSQL or the MongoDB driver for Cosmos DB. If you're looking to model the physical world with interaction, I encourage you to really check out the Azure Digital Twin service. It's enabled the creation of knowledge graph based on digital model of entire environments. This slide is a quick recap about the injection technology you can use depending on your choice of storage for IoT data. And we will see that you can combine this different ingestion technology if you want to store your data into multiple data sources. If you want to see how you can export your IoT data to a data lake or to an existing data warehouse, I invite you to check out the on-demand version of this talk. So we saw that there is a solution to put your IoT data pretty much where you want. But is there a specific data store that really shines with IoT data? Actually, I can tell you about two different stores. The first one is Time Series Insights. We've already seen that Time Series Insights can ingest IoT data easily. You can also create time series hierarchies, allowing you to execute that query about the average temperature of building I told you about earlier. You can also get this aggregated data out of Time Series Insights easily. We'll see this in a few minutes. You may be thinking, as a volume of IoT data is important, but the second preferred destination for IoT data would be a data lake. However, a lot of organizations today are unfortunately not yet ready to really tap into these data stores to get inside and to answer the dashboarding needs. They tend to favor the existing data warehouse infrastructure with data ready to be analyzed and great security features. With Azure Synapse Analytics, we are bringing you the best of both worlds. Synapse can query unstructured data sitting in the data lake while maintaining a classical table structure you will find in any data warehouse. Due to its distributed nature, compared to classical data warehouse solutions, Azure Synapse Analytics can help you tap into a huge amount of data, a huge volume of data within seconds. We just saw that integrating IoT data in your data analytics landscape is possible. Now let's see some concrete examples on how to get insight and actions from your IoT data. One of the most straightforward ways to use your IoT data is by augmenting existing dashboard with them. On the screen now, you can see a Power BI report made by the IT department of the well-known Contour Society. On top of several traditional data, you can now have at the bottom of the reports new data coming directly from an air quality IoT mesh deployment. So let's dig into how this report is created. Existing data come from operational databases. The IoT data come from two distinct data sources. Air quality alerts, which are shown at the bottom left of the report, are stored in an Azure SQL database coming from a Stream Analytics job. This job will only output a new line in the Azure SQL database when one of the sensors goes above a specific threshold value. Hopefully, this SQL table will contain only a very few lines. The graph at the bottom right is a bit different. It's a graph of sensor readings from all the IoT deployments with an interval of a minute. Here, all the processing is done in time series insights. We are just exposing this data within Power BI. Using IoT data in Power BI and exploring historical data with Synapse Analytics are two of the demos of the on-demand version of this talk. Data engineers are mostly asked to work on historical data. And with Power BI and Azure, they can also easily work on real-time analytics. By using Stream Analytics, you can process, aggregate, and filter data coming from IoT Hub in real time and outputting this data to several destinations. For this example, you can use the streaming data tile within a Power BI dashboard to display this data in real time. For creating this dashboard and all the real-time processing, there is no code, no background servers, no server to deploy. You just have to write a simple SQL query. That's it. But why limiting yourself to crunching and displaying data? When you know how to use Stream Analytics, you're just a step away from executing your code, or maybe even better, a workflow. Here, the same Azure Stream Analytics job is also launching the execution of an Azure Logic App. Azure Logic App is a no-code serverless workflow service in Azure, allowing me to execute action in a wide range of applications, like in this case, sending a message in a specific channel in Teams. Sending real-time alerts to Microsoft Teams and creating a real-time dashboard in Power BI are two of the many demos you will find in the online version of this talk. You can watch this on-demand version of this talk at aka.ms/IoT40/watch. You can also find all the session resources in the IoT Learning Path GitHub at aka.ms/IoT40. Maybe you want to learn by doing, like me. If so, I really encourage you to check out this collection of Microsoft Learn modules. Microsoft Learn is a free online learning platform where you can complete interactive learning exercises. And I will finish by crediting this open source resource that helped me to make this talk, and also by thank you again for attending this session.
What a great session, Christopher. Really like that.
Thank you.
First question I have in mind that popped in my mind was, like, we're talking about big data and everything. So like big data means a lot of data.
Yeah.
So is there a limit on how many data can we put in Azure?
So it would depend on which data store you will land your data into. If you're using data lake, it's pretty much unlimited, because the way the data lake is structured make it possible that we can scale by just adding servers. It's Azure doing it, it's not you, obviously. But if you actually pop up the Azure portal right now and try to upload an unlimited amount of data, you will hit a soft limit, because there is some soft limits in every Azure account we create, just to prevent you from doing any mistakes that will, I don't know, generate petabyte of data you don't need and you will actually pay for.
Yeah, because you can create many different storage account, and every storage account, what's the limit today? Like the soft limit, like it's a big, it's in petabyte, right? It's like, yeah, it's huge. So I'm guessing like yeah, feel free to try it if you want. If you have a big wallet enough, I don't know, like not even. It's not that expensive, the data anyway.
No,
Okay.
and you can tier the data because in storage account we have different tiers like hot, cold, and archive tiers. So maybe for some usages you don't need to actually have ready at hand all the historical data. Maybe you need to have access to, I don't know, 1 or 2 years of historical data, and for data that is older than this, you can wait a little bit because it's only if something happened that you really need to analyze it. And so you can lower the cost of storing all this data.
Oh, okay. So is it what we mean when we talked about, like, when I read and I see like the hot path and the cold path, is it what it means?
No, not really. The hot path and cold path are a way of processing this data in 2 different ways. The hot path is what we also call the real-time path. So, for example, with my air quality demo, if the air quality is going nuts at specific time, maybe I need to send an alert to the mayor, send an alert to the fire station because something is happening and we need to take action right now. But if we want to look at trends over a long period of time, we don't need the same amount of real-timeness. So we can wait a little bit longer to make this analyze. And this is what we do in the cold path.
Oh, that totally makes sense. Okay, so let's go with the question of the chat. So we have Matt here as asking, my device produces a lot of data. Is there possible to filter the data before storing it?
Absolutely. There is different ways of doing it. If you can have if you're leveraging IoT Hub and the Azure IoT Hub device SDK, you can add properties within every message sent by the IoT device, and you can filter out this data very easily right within IoT Hub. So that will be the easiest way of doing it. Unfortunately, you will need to make some changes in your device code to use that solution. So if you cannot do this because your IoT device is already in production or whatever, you can leverage Azure Stream Analytics also to do this kind of filtering. In this case, you will maybe not do any aggregation, like time aggregation, but you can do filtering and you can do also data enrichment. So add reference data with the data generated by the IoT device. The basic example is an IoT device sending a message a fixed device will probably not send this position. But you have somewhere a SQL table with like the name of my IoT device and where this device is installed. If you want to have this data into the message itself, you can enrich this message with Stream Analytics.
Okay. You mentioned an SQL database. So is there better databases when you do IoT solution project? Should I go no SQL or SQL is good?
Yeah. So most of the time we don't really recommend SQL databases for IoT projects because IoT can generate a vast amount of data. You saw this in the radio telescope example. And if you try to store petabytes of data into a SQL database, you may have some issues. So there is also databases that are better suited, like time series insight. But the key is probably that you will end up with several data sources or several databases for all your IoT data needs. Time series insight is great at looking for trends and looking for telemetry like temperature, that kind of things. But you will not be able to do specific analysis on top of it. If you want to create machine learning models from sensor data, then you need to actually store the raw data somewhere so your data scientists can access it and use it to train their models. So most of the time, as you said, we have a hot pass and a cold pass. Most of the time, we tend to store IoT data into several data stores. We replicate the data, but with a specialized database, and we try to understand when we need to expose the data and use the data, which data stores is the most suited for the specific data need.
Okay, yeah. So I could run something to aggregate and then do something to the data and then store it in a different type. So like it will it will be better in another type of database than my prime one for a different objective. Okay, that's cool. It makes sense also, right? So there's no the best one. It always depends, or favorite answer. So,
it depends.
So another question from Katrina was asking: once I get into the IoT hub, how can I get my data? Sorry, let's start again. Once data gets into the IoT hub, how can I get into the data store?
So I think the best answer is the extended on-demand version of this talk, because I have a few demos showing exactly that. To answer very quickly to Katrina, depending on your data stores, you can directly use IoT Hub. IoT Hub can directly output, for example, in Data Lake, your data in real time. And if you want to send it to a SQL database, you will need to add another Azure component, for example, Azure Stream Analytics or Azure Functions, to actually consume the message coming from the IoT Hub and storing it into your data store.
Very interesting. And the link just show up into the screen, so that's pretty cool. Oh, last question before we go to the next speaker. So what language or syntax do we need to learn to do big analysis in real time, or streaming data and all those things?
So it will depend on the technology you choose to actually do your big data stream processing. If you're using Azure Stream Analytics, which is probably the easiest way to get started on Azure, it's just a SQL language. So obviously we have a few specific SQL keywords, but it's like I do a select from IoT Hub into another database. That's it, and I can do where, I can do groupings, etc. It's very, very easy to get started. If you need to include, I don't know, for example, machine learning processing within this real-time streaming processing, maybe you will leverage other services like Azure Databricks Spark Streaming, and in there you can leverage Java. You can use Java or .NET platforms or Python platforms to implement your streaming logic.
Okay, so there's many different options. I may not need to learn something else if I'm already, for example, a Python developer, stuff like that.
Correct.
Pretty cool. Again, Christopher, thank you a lot for your presentation. I will let you join the chat, see if you can to help other people, and we'll continue with Sander, our next speaker.
Thank you. Bye-bye.
Bye. So this is the last sessions of the day. So session 5. Looking forward to meet Sander. Hello. How are you, sir?
Yes. Hello, Frank. Hello. I'm fine. Thank you. How are you?
I'm very fine. I feel like my wall need more devices. You know, you and Chris have tons of stuff. Mine white is kind of feels sad here. I don't know. I cannot hear you. I don't know if it's only me. Can barely hear you. Maybe a contact. Maybe check the contact of the mic or move it a little bit.
Should work.
Are you running a chat application? That could lower your volume, maybe. No?
Okay, is it better?
Yes, well, I can hear you.
Okay.
So, look like Sander have a little tech issue. I'm sure somebody will help him. In the meantime, apparently, I'm doing some time here. So, I don't have any magic tricks or dad jokes. Do we have any questions? Oh, he's back. That was fast.
Okay.
Oh, yeah, yay, I can hear you now.
Okay, very good.
I should have prepared a magic trick or something. End up with Frank. Exactly. Well, looking for your closing. So, you know, we say we keep the best for the end. No pressure, but
okay.
Looking forward to hear about you. So what's your presentation is about? I saw the title, but if you have like a one-liner.
Yes, I will give a presentation about IoT security, something about the reference architecture, and we do a presentation part regarding some examples with AI on the edge.
Okay, well, security, it's a very important. Everything is very important. So looking forward to learn more. I will let you do your presentation and see you after for the Q&A part.
Okay, very good.
Have fun.
Welcome to the introduction for Get to Solutioning, Strategy and Best Practices when Mapping Designs from Edge to Cloud. My name is Sander van der Velde. I'm an Azure MVP and also Azure IoT Platform Architect at Ethos. In this session, we will cover...
Sorry again. Maybe in the hijack of the mic, we don't see your slide right now. If you can share your screen.
Start sharing.
There it is. Excellent. So maybe you want to start over so we see all the best. And don't forget to click that little hide thing.
Yes.
Hide button. Look wonderful. Excellent.
Okay. Shall I continue? In this session, we will cover strategies for securing IoT device connectivity in edge environments, a common IoT solution architecture for a variety of business verticals, implementing artificial intelligence at the edge for intelligent video analytics. Let's go ahead. Let's begin by addressing the elephant in the room when it comes to Internet of Things, the concept of security. How do we enforce security in solutions that typically require the use of sensors in the real world, potentially in publicly accessible areas? As you might expect, it all begins at a device, but it must also be addressed in the communication layer and within the cloud environment itself. We'll look at how Microsoft provides security for IoT solutions in each of these areas. Security concerns related to IoT is a very real thing. During the October 2016 Mirai botnet attack, roughly 100,000 IoT devices were taken over by hackers and turned into a botnet. That botnet was then used to launch a distributed denial of service attack, impacting the east coast of the United States for a day. No Netflix, no chat, no online shopping. Or imagine hackers getting access to your corporate data by way of a fish tank. This happened recently to a big casino in Las Vegas, where attackers used a vulnerability in the aquarium thermometer. They got a foothold in the casino's network and targeted the high roller database. In the 2017 Triton attack, hackers intended to manipulate emergency shutdown protocols to keep plant systems running, while they gained more control using malware. Thankfully, that malware accidentally triggered system shutdowns, but allowed the attack to be noticed and mitigated. So, security in IoT solutions is paramount. IoT devices often have access to mission-critical controls, sensor data, and potentially real-time video in vision-based scenarios. Securing IoT solutions requires mitigation across all relevant data pathways, beginning with the devices, all communication layers, which typically involves connecting to a cloud-hosted environment, and the cloud environment itself. Microsoft IoT Services is built with security from the ground up, beginning with the device security, communication security, and within the Azure Cloud Services. Whether you're building an IoT solution using a microcontroller like Azure Sphere, and that's a device that looks like this, or an Azure IoT Edge solution, the IoT security architecture from Microsoft has you covered. It provides dashboards for monitoring the security state across all device workloads from within Azure Defender. This integration is built into the Azure device SDKs, the Azure IoT Edge runtime, and into the silicon, this device, into the silicon of this device, the Azure Sphere. So building your solutions with Azure device SDKs, Azure IoT services, And hardware means that security integration is available to your solution right from the start. Within the Azure cloud itself, you can rely on the security and disaster recovery options available in each of the 60 plus available global data centers. This offers low latency connectivity no matter where your devices are in the world. It also enables multi-region failover protection to ensure your IoT solutions are always up and running. If your solution requires industry-compliant standards, we welcome you with an updated list of currently 93 compliance offerings. In the follow-up presentation of this introduction, we will dive into various secure network environments. For example, if you have legacy devices unable to run the secure device SDKs, they can still be secured using an IoT Edge gateway. This offering allows for a variety of configurations, existing within factories, offshore or intermittent remote environments, or even air-gapped internal networks with no outbound internet access. We show you that Azure IoT services can be leveraged in even the most challenging environments. We've explained how Azure IoT services can be made secure. We continue this conversation with an architectural perspective. How might Azure IoT solutions be relevant to your line of business? Recent innovations accelerated the growth of IoT solutions across a large number of industries. It's no surprise that much of this innovation has been iterative. It begins with nearly limitless computing and storage via the cloud revolution, which allows processing data transmitted by devices at a massive scale. We see the full circle effects when devices on the edge have increased computing power. This unlocks new possibilities because even devices smaller than a cell phone can now run accelerated AI workloads. As innovations in cloud increase, we again see additional benefits, for example, with the adoption of digital twins. This replicates physical environments into virtual space, allowing for a one-on-one mapping of real-world environments in the cloud. We refer to this paradigm as digital transformation and see the potential of Internet of Things and AI at the edge as the forerunner of mainstream AI. AI is no longer an inaccessible field riddled with complexity and cost. It's available now and invites all of you to get started with it. In every industry can benefit from increased value, reduced waste, or enhanced procedures when adopting IoT. Here are some examples. Many businesses are facing the effect of return to work related to COVID-19. Automated systems for screening and reporting visitor well-being are already demonstrating safety for both customers and employees. Within the medical community, the ability to monitor patients in real time is even more critical in times of surge capacity, and it helps to identify and assess patients under quarantine. The futuristic vision of self-driving vehicles is at its heart an IoT solution, demonstrating just how fast insights can be enacted upon, up to recognizing potentially catastrophic events in real time. The effect can be extended to smart factories to reduce downtime. This allows for increased production and better overall equipment effectiveness. Similarly, energy companies can now mitigate real-time demand spikes and provide value to customers by automatically dialing down HVAC energy usage if needed. In retail areas, it is possible to measure customer behavior, allowing for enhanced customer experience by reducing shelf vacancy, optimizing reorder frequency, and product suggestions while the customers are shopping. In all of these examples, the pathway from device to the cloud to line of business applications is very similar. Of course, there are many technology variations in the real world, but the workflow from using things to produce insights, which leads to actions, is common to all IoT solutions. This fundamental concept can be applied to a host of business scenarios to create relevant IoT solutions that leverage real-time insights and actions. Microsoft provides an IoT the reference architecture that employs service offerings designed especially for this common workflow. Our things are IoT devices either directly connected to the cloud using the secure device SDKs or by means of an IoT Edge gateway. Both in the Azure cloud and on the edge, we can process data in flight and operate on the insights contained within. Time-critical insights are put into a warm path storage for immediate usage, or these are offloaded into cold storage for archival purposes. Line of business applications enable you to take action. We have covered the theoretical concepts. We now show you how to develop state-of-the-art AI at the edge solutions using the latest concepts in computer vision. To demonstrate this, we introduce a real-world project developed using NVIDIA embedded hardware and an Azure IoT services that consumes multiple video servers to produce insights. Especially, we will develop a solution to target an NVIDIA Jetson device. That's a device like this, and it has onboard GPU for accelerated AI inferencing. We provide full instructions to enable you to replicate this solution, and we point out areas of customization. We will show how to configure an IoT Edge runtime on an ARM-based Jetson platform. That's the device that I just have shown. And we will show you how to capture training samples and how to train custom object detection models with the custom vision AI service from Microsoft Cognitive Service. We also explore how to use an Azure IoT Stream Analytics job to filter out object detection insights. With the reduced insights flowing into the IoT Hub, we visualize them in near real time in Azure services like Time Series Insight or Power BI. This solution is aligned with the Azure IoT reference architecture. Our IoT Edge device allows for direct communication to an Azure IoT Hub. On the Edge device, we employ an IoT Edge module with a custom vision object detection model from Cognitive Services. The object detection output is routed to a Stream Analytics job, which is also deployed as an IoT Edge module on the Edge. Filtered results from this job are sent to the cloud using the IoT Hub communication to business integration services, allowing for near real-time display. In addition, machine learning ops is used to capture camera frames using a camera tagging module. These could be frames that are hard to process for the currently deployed object detection model. So these frames are mirrored to a cold storage in the cloud and inspected by a data scientist. Those can then be used to enhance the model using the Cognitive Services custom vision service. And the enhanced model is then deployed again to the cloud, from the cloud to the edge for even better object detection. By now, you are ready to apply the Azure IoT reference architecture to your solutions. Microsoft's own Project 15 adopted the object detection model sample for, you guessed it already, elephants, and update the business integration to visualize where elephants have been seen on an interactive map. This helps the conservation and protection of the world's elephant population. You can learn more about Project 15 by visiting aka.ms/project15. For links to the relevant documentation, demos, resources, and the follow-up presentation, check out aka.ms/IoT50/resources. If you are interested in using the presentation and the recording of this event in an event of your own, the materials can be found at GitHub at aka.ms/IoT50. If you are interested in other topics covered in the IoT learning path, you can find them all at aka.ms/IoTLP. We have curated a collection of Microsoft Learn modules that are related to topics in this session. This will allow you to learn in an interactive way how to securely connect IoT devices to the cloud, build intelligent edge applications using Azure IoT Edge, create solutions with a software as a service IoT platform named IoT Central, And you will learn how to implement Stream Analytics job both in the cloud and on the edge. This presentation and the associated Microsoft Learn modules also help on the path to official certification. To obtain accreditation that helps you stand out as a certified Microsoft Azure developer, IoT developer, we recommend checking out the AZ 220 certification exam. You can find out more details about certification and even schedule an exam today at ak.ms/IoT50/certification. For more free interactive Learn content, check out Microsoft Learn to begin your own custom learning path with resources on the latest topics and trends in technology. My name is Sander van der Velde. Dankjewel. Thank you for attending this session.
Way! You did it! Awesome presentation. There was a lot of information over there, so great job.
Yeah, there's lots to tell about Azure and Azure IoT.
It's definitely a hot topic, and today with the tech that is ready and everything, I think it's the best time to jump in. So yeah, definitely very interesting, and all those topics are very exciting also to do. Yeah, so we have a few questions. So the first one from Steve was, how does Azure and assure the secure transport of the IoT data to the cloud?
Well, if you are using the Azure IoT SDK, IoT SDKs, you will use transport security between device and cloud. And of course, each device has its own credentials. So you cannot mix data coming from multiple devices or try to pretend you're a certain device.
Okay, cool. Then we have another question from Jess, who's asking, does the edge gateway needs to be connected all the time to the cloud?
No, it does not have to be connected all the time. It has to be connected at least once when you set it up. And if the internet connection breaks for a certain time, messages which are intended to be sent to the cloud will just be held up on the edge. They will store it in a temporary storage, persisted, and once the connection comes back, the data will be sent to the cloud after that. And it even comes with a priority solution. So messages with a high priority will be sent earlier than all the other messages.
Okay, and I'm assuming like if there's possibility of conflict or something like that, like in your code or something like that, you need to think about that. Like if your solution can be disconnected, then.
Yes. Although from a container, a module perspective, they are pretty unaware about having a connection or not with the cloud. It's the event hub, the representation of the IoT hub on the edge, which will take all the heavy loading.
Ah, okay, interesting, cool. Okay, another question we have from James. How can I make sure, how can I put that? English is hard this morning, apparently. It's morning for me, so. How can I make use of all the data for my devices produce to provide AI capability in my IoT solution?
How can I make? Well, I suppose it's both AI at the cloud and on the edge. The idea is that when you have AI running on your edge solution, you can already make decision on premise, and all the data that is sent and that is targeting the AI capabilities can already handled over there, so that for example, limits the amount of data sent to the cloud, which is of course cheaper, or you have a better reaction time because the loop for taking action is smaller, and of course it still runs when the connection is not running, is not available to the cloud. The edge device will run forever until it makes a connection to the cloud again.
Very interesting. Well, thank you, Sander. It was a great presentation. So we'll let you go in the chat, see if there's more question there that you can answer. And for us here, we'll go now for sharing some slides just to tell where people, what's the next step, where people can go. So let's do that. So here, so the next steps, don't forget about that 30 days to learn IoT. It's a very interesting challenge. And also there's more information here if you want to learn more. All the decks, the decks are available over there, so feel free to go there. Again, thank you a lot for all the viewers, all the speakers. It was an awesome presentation. I learned so much today. Very happy and looking forward to see more of those IoT projects on the social media. See you soon. I'm Frank. Have a good day.